Hi, this is the demo for the DOSP project part 2, where we create a Twitter engine using a client-server communication WebSocket model. So we have successfully completed all the fundamental requirements, and we have also completed the bonus part. We'll first go through the code, we'll first go through the project demo, and then we'll look at the code walkthrough. So I'm going to run my engine over here, and then in this terminal, we are going to simulate a user. As we can see, the server has connected with the user using a socket. Now the user has different options such as sign up, login, and server status. We will be signing up a user and then we'll start posting tweets. Now during the sign up of a user, we can see that the server shares its public key to the user, which we later use in HMAC signature verification. Now the user has been logged in. As you can see, the ID we entered, and the communication is through JSON APIs. We will post a tweet for this user. We'll enter a hashtag and a mention. Now, as we can see that the tweet has been posted. So we will look into this in a little bit of detail. Now, before posting the tweet, there is an HMAC signature validation that is being done. So the user creates a shared secret key using its own private key and the server's public key, which it shared in the beginning. And using that shared secret key, it digitally creates a HMAC signature and signs the tweet. This signature is being sent to the server over here, and the server now creates its own HMAC signature. Then the server HMAC signature and the user's HMAC signature is compared, and if they're equal, only then a tweet is posted. So that was the posting tweet. We'll try and post one more tweet so that we can query all those tweets later. We'll enter another hashtag and another mention. So as you can see, there is one more HMAC signature that has been created, and that is verified, and the tweet is now posted. Now, after this tweet posting, we'll try and query the tweet. To query the tweets for the user, we'll choose number 4 option, where we to query tweet history. We'll enter user ID. And as you can see, the server has been sent a request of get history, which is returned over here, tweet, the different tweets, the data is Bitcoin and the data is Ethereum, the hashtags and tweet ID and the mention numbers, everything we can see here. Now, the next step which we are going to see is the logout operation and a challenge-based login. So we'll log this user first out of the system. As we can see, the user is now logged out, and we go back to the main menu. Now here, we'll log this user back in. We enter the user ID we want to log in, and this is a challenge-based login where we did not have to enter the credentials. So we will look into this into a little bit detail. When the user tried to log in, the server started a challenge. This challenge was cached for 1 second. The timing is 18:52. This challenge was sent for authentication back to the user. Over here, it enters the authentication phase, and this is the received challenge, which is the same as which the server had created. This challenge is now encrypted by adding up time padding. The time padding is added over here, and then it is digitally signed. This signature is now sent as a cryptographic signature in a JSON API back to the server. Now the server also creates the server removes the time padding from this cryptographic signature. And based on its current time and the received challenge, it now verifies the signature. Now, since the signature has been verified, the user is logged in. And as you can see, the challenge which was initially created has expired at 18:53, and it was 18:52. So the challenge was cached only for 1 second. And only after this challenge-based authentication was passed, the user was logged in. Now, we will again try to query its tweet. And we can see this is the very same user which has been logged in. We can see both the tweets. So in this module, we have completed the introduction, the sign up process, the login, logout process. We posted a tweet and we queried some tweet history. Similarly, there are other functions like subscribe, query by tag, and query by mention, but in the interest of time, we are now going to move towards the code overview. Now, before I move to the code overview, there is one more thing that we can look. So we have also created a display server, which shows the current status of the server. So now we will log this user out. So we have launched the display server in this terminal. And as you can see, it is getting real-time updates every 2 seconds. And we will try to sign up one more user to see if the status is being updated in real time. We'll choose sign up. We'll enter the user, which is some different user, 1287. We'll enter name, say Guru. And as you can see, the online users has been changed to 1, offline users is 1, tweets and system is 2. Now, if we just post quickly a tweet, which is say Dogecoin, tweet is hashtag Elon Musk and mentioned. Now you can see that the number of tweets has also increased. So this way we have also added a live server in the system. Now we will move to the code walkthrough. So here we will do the code walkthrough. In code walkthrough, the left-hand side is the engine and the right-hand side is the simulator. So when we look at the engine, our directory structure is we have a main engine over here. We store the different actors in this file where we have the sign up actor, we have the tweet actor, and we similarly have different actors for querying the tweet history, retweeting, subscribe, query by mention, query by tag, and the display actor, which we used for the display server we saw earlier. Then we have a helper function where we use different functions or your utility functions, such as we register a user, sign up user, map updating. Similarly like that, we have different functions over here. We're adding retweets to system. We're adding a subscriber. We are adding mentions. And then we're adding tweets, which in itself is adding tweets for the different user, updating the tags in the database, updating the mention. And it also goes through the different subscribers that a tweet that a person has mentioned, and then it updates their database also. So these are the helper functions. Then we have the storage data structures where we store all our maps and dictionaries. Then we have a JSON messages file where we store the different JSON message types. So this way it's easier for us to manage the all JSON APIs, the all JSON response body types. Now, if we go back to the engine, we'll look at some important parts in the engine. So in engine, we'll go right at the bottom and see we have different socket managers set up. For whenever an API is hit, there is a respective socket manager that actually performs the different task. For example, if we look at the tweet manager. So the tweet manager reads the incoming message, calls the tweet actor reference for this message, passes the data, the socket session, and the socket ID, so that the response is also handled. This way, we have different response handlers for the different actions, different managers for the sockets. Now, we have, and over here, we have created different actors. Now, we will look at one particular actor, which is the login logout actor. Over here, we are performing the challenge-based login. So if we look at the login actor, whenever we create a challenge-based login, the server side creates a challenge and then sends a JSON response for authentication, which is the next step, which we saw in the video. Also, one thing I would like to state, which I would like to mention, is that we have also incorporated proper error handling in every step of the way. So if the authentication fails, we tell them that you need to register, and then we have different over here. If authentication fails, we have an authentication success message. We have error handling over here. Then we have error handling over here. So we give proper error management also. Now we will look at the simulator code structure. Over here we have the simulator.fs file, which does the main task, which we will look at over here. In the main function, we have the endpoint dictionary, which registers all the different sockets. It opens a WebSocket for the different APIs, and it adds them to a dictionary. Now, after adding, it registers a response or a reply handler, which whenever the server sends a reply, and on receiving a reply, different handlers are registered. And for example, if we look at the login handler. Now, if we go to the login handler, and as we can see, if the server sends an authentication message from here, this is read from the login handler. Now the authentication message is read, they receive a challenge, and as we saw earlier, they add a padding, And after signing with its own signature, it is sent back to the server. Now, when it is sent back to the server, it is a type authentication message. Now, in server, we initially saw the login type message. Now, if you look at the authentication type message, it says, hey, I have received a response for authentication from the client. Then it creates its own signature, then verifies the data, and if the authentication is confirmed, it receives the success status over here, which is handled in the login handler over here. And when the login is confirmed, we open all the sockets for the different APIs, such as querying a tweet, etc. And then we log the user and display the menu. Now, after this login, we have, so if you look at the simulator more, when the program enters into the main function, it displays the menu or a choice menu to the user, which we saw in the demo. And whenever a user enters a menu, if he wants to sign up or if he wants to log in, so then the simulator actor over here is given that command in the form of a serialized JSON. This is sent to the simulator actor and it does a matching. So if we receive a connection attempt or a login or a logout, it opens a respective socket and it sends the message. This message is sent to the server, then server performs a particular task. It responds with the particular response, which is handled by the response handlers. Also, we will look at over here how we have configured the tweet actor for HMAC signature. So when we post a tweet from the server side, as you can see over here in the tweet, yes. So when we see the tweet, we generate a shared secret key, we create an HMAC signature, and then after creating the signature, we send the original JSON message and the signature, which is received over here. And we verify that if this user is even a valid user in the system or not. Then after verification, we'll look at both the signatures and say that, okay, the tweet posting is done. HMAC authentication passed and tweet has been posted. Otherwise, it responds with failure or failed at HMAC authentication, or if it failed at that the user is not even registered. So this way we have implemented error handling in everything. Also, in the sign up actor, whenever a user signs up, we store the server's public key in a dictionary, and when we add the keys to the database, we update everything. Now, if we look at some of the utility functions, we have a credential map where we are storing the shared secret key and the server public key. Similarly, we have different functions over here. Now, if we look at the helper functions in the simulator side, we have few helper functions. The one important one is the enabling and disabling of all sockets. This is particularly important because when a user has signed in, we need to open all the sockets for the communication to process. And when the user logs out, the socket should be closed. So we disable all sockets and enable all sockets. So when a user signs in, so if we go to the login handler, we see we have enabled all sockets over here. Similarly, we disable all sockets in the logout handler. This is our server status handler. We have a tweet history handler. Then we have a response handler for the common operations. We just say what the operation was and it's successful or not. Then we have the logout operation. And as you can see, we have disabled all the sockets over here. And whenever making a connection to a socket, we must make sure in order to make the system more robust that the socket is not already open. So we check if the socket is alive or not. If it's not, only then we send the message. So this way we implemented challenge-based login, JSON API-based communication, and completed this Twitter project. Now we have some hard-coded hashtags and tweet lists for references. And this is an extension of the project part 1. And in the end, if we look briefly at the WebSocket interface, which we have created, over here, the server is running on a local host on a port mentioned, which is hard-coded over here. And on the client side, it is running on the same port so that they can connect with each other through WebSockets. And in the demo, we saw that the socket IDs are also visible through which they are connecting. This is the display menu, which is being showed in the beginning. And this is how we have completed our entire project for the Twitter-based CLI model, in which the user and the server interact with each other using a socket-based communication and with the help of JSON APIs. We completed all the bonus operations, such as the encryption, the HMAC signature, and the challenge-based login. Thank you.